So the sign charts that we're going to do today are on the little number lines. They get used a lot in calculus. So we're going to use them for quite a few things, but then Mr. Ackerman poked his head in here the other day when I was doing this, and he was like, y'all are going to use those like crazy in calculus. So I'm just telling you that. I'm not lying to you. I'm not making it up. They're easy, though. They're kind of, and once you get them figured out, it's not that big of a deal. Okay, so we're going to talk about polynomial inequalities today. And it says, given a polynomial function, so we've been talking about polynomials, a polynomial inequality has the general form of f of x is greater than 0, greater than or equal to, not equal to, less than or equal to. Basically, an inequality means it's not equal. Okay, so for the inequality f of x is greater than 0. Now, what does f of x always represent? Y. Okay, so if y is greater than 0, that is true when f of x, or y, is positive. Anytime we talk about the value of a function, is the function positive or negative, you're always talking about the y values, always. So then if I have an inequality f of x is less than 0, that's true when f of x is negative. So it says, look at this function. So they already have that function graphed for us. And then it says to name all of the intervals for which f of x is greater than 0, or when is the function positive. So that means all of my y values would have to be greater than 0. So that would be here, here, and here. Okay. So this says greater than 0, not greater than or equal to, so I don't get to include the zeros. We're talking about the y values being positive, but remember, the intervals that you write are always intervals of x. We talk about y, we write about x. So my function is positive, my y values are positive, starting out here when x is at negative infinity. And then I move along the x-axis until I get to here, and that's it, negative 3. So from negative infinity to negative 3, the function's positive. I don't include either one of them because remember it's not greater than or equal to 0, it's just greater than. I start back over here at negative 1 and go to 0. And then I start back over here again at 1. And then the function's positive until x gets to infinity. Everybody okay with that? That makes sense? Okay. So then I want to name all the intervals for which f of x is less than 0. That's this part here and this part here. So the function starts to become negative at negative 3. Remember, x is negative 3. It's negative from negative 3 to negative 1. Both of those are open because at negative 3 and 1, it's actually 0. Then I start back over being negative at 0 and going to 1. Any questions about that? That makes sense? Okay, so I'm spilling this all over me from a sealed bottle. Okay. All right, so here's what you do with the sign chart. I'm going to run you through the steps. I'll talk you through them. They won't make a whole lot of sense till we actually do it, but there's the list of what to do there if you need it again. So we're going to set the polynomial equal to 0. We can do that. We're going to completely factor the polynomial and find the zeros. We can totally do that. We're going to plot the zeros on a number line. We can totally do that. Then we're going to choose test points in each interval, substitute the test points in, and I'll explain that a little bit better when we get it. That's super easy. We shade the sign chart, which we can do, and that's pretty much it. So the only thing that kind of you don't already know would be able to figure out what it's talking about is choosing the test points, but that's super easy anyway. So here's how this works. It says to create a sign chart. So I don't think you have these extra little marks here. I don't know. You know when I say sometimes my fraction signs disappear, that's where some of them landed, and I have no idea why. All right, so the first thing we're going to do is set it equal to 0 and factor. So this is a quartic, but it's set up like a quadratic, so it's pretty easy to factor. A is 1, so I can go ahead and start with x squared and x squared. This is positive, so the signs are the same. This is negative, so they're both negative. What would my numbers be? Good, negative 1 and negative 25. Then can I factor some more? Yes, I can. So 0 equals, and then I'd have x plus 1 times x minus 1 times x plus 5 times x minus 5. Okay, so that's completely factored. Going to find my zeros. And in this case, I could do plus or minus 1 and plus or minus 5, but I'm going to list them out in order instead because we're going to have to put them on a number line. So I've got -5, then -1, then 1, then 5. If you did plus or minus 1 and plus or minus 5, it would not make it wrong. So then I've given you a line. We're not going to worry about putting all the little tick marks on there. Just kind of, in general, space it to where it looks semi-okay. So if I start with a -5 here, then this would be a -1, then maybe 1, then 5. Doesn't have to be perfect there, okay? So here's how we choose test points. Now, all we care about is the function positive or negative at certain spots? And I don't care about the actual number. This number line basically represents your x-axis. And so since these are my zeros, this is where I would cross the x-axis, right? And when you cross the x-axis, that's where you go from positive to negative or vice versa. And so I want to know, so I should change at maybe at each one of these. It doesn't always alternate, but so we're going to choose points that aren't these, because I know at these, it's 0. So I'm going to choose a point between -infinity and -5. Okay, so I'll go with -6. There's no reason to get crazy. I use my fully factored form right here, and I substitute it in. Now, when you look at this, like if you're doing this on Delta Math and it shows you an example, they actually find the actual numbers. That's totally unnecessary. I don't know why they're doing that. I mean, you can, but it's totally not worth your time. All we care about is positive or negative. So if I substitute in a -6 into this little binomial right here, that would give me a negative, I mean, it gives me a -5, but all I care about is the fact that it's a negative number. So I get a negative in this one. I take that same -6, put it in here, it would make that one negative. -6 in here makes that negative. -6 in here makes that negative. Does that make sense? And then if I multiply those together, whatever the numbers are, if I multiply negative times negative times negative times negative, what's my number going to be? Positive. So this is positive overall in that section. Okay? We don't care about the actual number, just is it positive or negative? So between -5 and -1, let's choose -2. So if I put -2 in here, that would give me a negative number. -2 in here would give me a negative number. -2 in here would give me a positive number. -2 in here would give me a negative number. Do y'all understand where I'm getting my negatives and positives from? And when I multiply all that together, what do I get? Negative. Between -1 and 1, I can pick 0. 0 is always the easiest because then that'll give me positive, negative, positive, negative. So that's positive overall. Then between 1 and 5, I can choose 2. Put 2 in here would be positive, and then here, positive, here, positive, and then negative. So that's negative overall. I could pick 6 over here, so that's going to give me positive, 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 and it's positive overall. So I have put stuff on my number line. I've decided if the function is positive or negative in between those, and then it tells me to shade. So if this is like my x-axis, then above the x-axis is positive, below the x-axis is negative, positive, negative, positive. And this one just alternated back and forth. They do not always just alternate back and forth. If they did, all we'd have to do is find the first one and know that they alternate, but it doesn't work that way, okay? We're going to take this a little bit, the next step when we get to the back of this, but we're going to do one more and then I'll show you how this helps you with your polynomial graphing. All right, so if I look at number 2, or do y'all have any questions at this point? All right, so number 2 is already factored for me. That's great. And then, so I need to find my zeros. And I want to put them in order. So I've got -3, 1, and 5, right? So on here I'll have a -3, 1, and 5. And whether or not they're actually spaced out to scale, that really doesn't matter. Sometimes it's not a bad idea just to space them out so if you have room for your little positives and negatives. Okay, so let's do, oops. So I'm going to put this, I'm going to use -4, I think here. -4 in here is negative. Negative 4 minus 1 would be negative. Negative 4 plus 3 would be negative, but then what happens? I square it, which means no matter what I put in here, once it gets squared, that one's going to be positive every time. So those three get multiplied together, and it's positive overall. Between negative 3 and 1, I can pick 0. So that'll give me negative, negative, positive. Again, that's positive overall. Then I can choose 2. That would give me negative, positive, positive. And 6 would give me positive, positive, positive. Okay, so I've got positive, positive, negative, positive. Okay, so think about the polynomials we just sketched, right? You just had to sketch some. And if I have a factor with an even exponent, what happens when I'm sketching? It's tangent. That's where your bounce was, right? Because it's tangent. And so look here at negative 3. You see how this is a 0. My function's positive, but then it stays positive. It's because it bounces off the x-axis because it's tangent because of that right there. So really from this, I don't know what my y-intercept is, but I could sketch my polynomial. Okay, this is a 4th degree polynomial and it's positive. So we already know that our end behavior is up, up. Well, look at this end behavior here. This is up, this is up. From this, just this, I'm up here, I can bounce, and then I have to go back down here and come up through that one. And that's basically what my function looks like. That make sense? So here, this again is a 4th degree, so I should have up, up in behavior, which I do. This one just goes, it's here, I go through here, back up, back down, back up, something like that. Okay? See how that works? All right, good, because we're about to do that right here, where it says sketch a graph of the polynomial function with x-intercepts and signs indicated in the chart below. All right, so they've given me a sign chart. The one thing the sign chart doesn't tell me is the y-intercept, but that's okay. I have, let's see, this is at negative 6, negative 4, negative 1, and 1. All right, so I'm going to put those on here, just like we sketched before. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I have a point at negative 6, negative 4, negative 1, and 1. Are there any bounces here? Nope, just because it switches back and forth, right? And I start positive and I end positive. So I'm going to start up here. I'm going to go through this x-intercept through this one, through this one, through this one. I have no idea where my relative maxes and mins are. Maybe I should have gone way higher or way lower, and I don't know what my y-intercept is, but that's the general shape of that from the sign chart. Okay? And there will be a lot of what you do when you start applying this stuff that really all you care about is between these two, the fact that the function's positive for whatever you're looking at. Okay? We good? All right, why don't y'all try to graph number 4. Okay, so I've got to start negative, negative, positive. Oh, my finger was not good. Negative, positive, negative. I have to stay negative, so I'm going to bounce, and then something kind of like that. Just always try and make it curvy and not pointy, and you'll be fine. Any questions at all? Beautiful. Now, let's look at how this is going to help us solve an inequality. Still going to make a number line. Okay, so basically we do the same thing. Use steps 1 through 5. For step 3, we used opened or closed points depending on the inequality. So we didn't really even put points on the other ones. They're intercepts, so we could have. But here, if it's open, it gets an open circle. If it's included, then it gets a closed circle. So you just got to pay attention to that. And then we have to write the solution to the inequality. So the first thing I have to do here, set this equal to 0. So I'm going to move this 10 squared over. So this is going to give me x to the 4th plus 4x cubed. Then I've got x squared minus 10x squared. So it's going to be minus 9x squared minus 36x is greater than or equal to 0. The next thing I have to do is factor. What do I always look for first when I'm factoring? The x, the GCF, right? So I have one. It's just plain old x. So I'm going to take this x out, and I get x cubed plus 4x squared minus 9x minus 36 is greater than or equal to 0. So then I have to keep factoring inside, but I can't lose my x, so I'm going to use a bracket here so I don't get lost in my parentheses. X, open my little bracket. Out of these two, I'm going to factor by grouping. I can factor out an x squared. That leaves me with x plus 4. Then I can factor out a negative 9, leaves me with an x plus 4, greater than or equal to 0. So that means I get x times x squared minus 9 times x plus 4, greater than or equal to 0. Can I keep factoring? Yes, I can. X times x plus 3 times x minus 3 times x plus 4 is greater than or equal to 0. All right, so now that it's all factored, my zeros, the smallest one's negative 4, then negative 3. Don't forget about this guy. He gets forgotten a lot, but he's important. 0 and 3. Right, so then I'm going to put that on my number line. Got a negative 4, negative 3, 0, and 3. And since this is greater than or equal to 0, these are all closed circles. We get to include the 0. All right, so over here, I think I'd start with a negative 5. So negative 5 in here clearly is just negative. Then this would be negative, negative, negative. That's positive overall. You finish up that sign chart. Then we'll talk about the intervals we got to do. Oh, here I'd have to use negative 3.5. You can't use 3 or 4. You have to use like the in between. So like negative 3.5. You don't have to get an actual value. So hopefully you should still be able to figure that out. Double check, make sure you agree with me, and then we'll talk about how we actually have to solve this one. Basically, that does solve our inequality for us. So since what I want this function to be greater than or equal to 0. That means that's when it's positive, right? Well, here's when your graph is positive, in those 3 spots. So then I just write the intervals for that. This function is positive starting way out here at negative infinity and going to negative 4. Because that's greater than or equal to, I include the negative 4. I never include infinity. Then I start back over being positive at negative 3 all the way to 0, including both of those. And then starting back over again at 3 and going to infinity. What questions you got? We good? Awesome. Then you try this next one from scratch. All your factoring and everything. You can do it. boy, set that equal to 0 and factor that thing. Here's where things got weird. First of all, factor out your GCF of x squared. You see that? You got an x squared, you can factor out and make your life a lot easier. Oh. And also, when you do these two, this one's going to have to be positive. You're going to get 13x. Yes. Okay, I think that's what was really throwing you off. But if you, and you're not wrong down here, like, so, well, this part is wrong. And like you can factor out the GCF at the end, but it doesn't come out right. This wouldn't be in, well, that would be an x squared. Okay. But it would be positive. And that would be positive. And then you can factor it out of that. So that's still negative. But when you take, since this was positive, you're just taking out a positive x squared. So that'd be a plus right there.
Right here?
Uh-huh.
Oh, yeah.
And right there. Like it should be plus in there. So there you go. And then from here, you can factor out your x squared and you don't have to start over. Once you get them, go ahead and get your zeros, get it put on the number line, see what you can make out of this. Got your sign chart down. See if you can write the intervals for the answer. You want it to be, this to be less than 0. So write what you think your intervals would be. Questions about the intervals? Do you understand why these were parentheses and these were brackets? If this had said less than or equal to 0 and these were closed, then I could have just gone directly from -1/3 to 4 because it would have included that 0. But since I didn't get to include it, I had to skip over it. Okay? Are we good with that? What questions you got? Anything? Think you can do this? You can do this. You got lots of time to work.